In this video, we're going to talk about related rates. So the volume of sphere increases at a constant rate of 100 centimeters cubed per second. Now the rate at which the radius r of the sphere changes when r equals to 3 is going to be 25 over k pi. We need to find k. So I'll start reading the question. Again, we're talking about the volume and we're talking about rate. Rate, it means derivative, directly. Now, how do I know what is the 100 centimeters cubed per second? It's centimeters cubed, it means volume, over time. So I start writing dv over dt equals 100. And we must write in this way because you're gonna see later on we're gonna write the rule and substitute. So dv over dt equals 100. The question is find the rate again, so find derivative at which the radius, so dr, changes. For sure the radius is changing over the time, and we can see this also from the unit, so centimeters per second, so dr over dt. I'm looking for that. Now, because we're talking about the volume of sphere, we need to know the rule for the volume of sphere, and it is equal to 4 over 3 pi r cubed. Now, whenever you have such a question, if it's volume or area, always we start the same way. I write dv over dt. If I have area, I will write dA over dt. Area or surface area, it means the same thing. So always we start this way, dv over dt or dA over dt, and then I start like this. I check what is the numerator here, dv, I write it, over. Now, I check the volume, is it related directly to t or related to r? It's related to r. So we have to move from volume to radius, then from radius to time. Okay, so the volume is related to radius and the radius is related to time. So I have to use chain rule. It will be dv over dr because the volume is related to r, multiplied by, now you stopped at dr here, so you should start again with dr over dt. If you forget this in the exam, always you start with the same numerator, dv, and then you check volume related to r, so it's over dr. If you write dr down, you should write dr on top, and the last denominator will be the same as dt. Why is that? Because if you think about this, by cancelling dr and dr, we go back to dv over dt, and always check your answer in the exam in this way, if you wrote it correct or not. So imagine you are cancelling. Do you get the same thing as the first thing you wrote? If yes, continue. Now, for sure we're not gonna cancel here. We wrote it in this way for a reason. So I replace everything I have. dv over dt, I know it's 100. dv over dr, this is the derivative. So what is dv over dr? It's basically v prime. Now, how do you derive the volume of the sphere? 4 over 3 pi is just a number. So basically you're deriving r cubed the same way you derive x cubed. So you bring the 3 down and you multiply it with 4 over 3 pi. It becomes only 4 pi. And you subtract 1 from the exponent, it becomes squared. So I will write 4 pi r squared times dr over dt. Now we're looking for that. Because it's multiplication, to remove 4 pi r squared, you divide here by 4 pi r squared and there by 4 pi r squared. This and this will cancel, and we get dr over dt equals, if you want to simplify here, divide by 4 will be 1, divide by 4 will be 25, so 25 over pi r squared. Now they told you how much is this when r is equal to 3. You will replace 3 now, so you get 25 over, instead of r, 3, so 3 squared is 9, so it will become 9 pi centimeters per second. So what is the value of k in this question? Will be 9. Another question. They're telling you the side of a cube increases at a constant rate of 2 centimeters per second. So we're talking about side, and it's related to time because we have rate, we have to write ds, s is side, over dt equals 2. The question is, what is the rate? So I need to use derivative of the surface area, so I'm gonna call it A over dt. So the rate will be changing over the time, that's why we write dA over dt. And how much is that? This is what we're looking for. Now, what is the area of a cube? I know a cube has 6 faces, and each face is a square. So the area of one square is s squared. So if you have one square, s and s, you multiply to get the area, it will be s squared. Because I have 6 of them, the surface area of the cube will be 6 times s squared. Now, the same way, dA over dt, always we start with area or volume, whatever I have, equals, I use the same numerator dA and I check. The area is related to s, so I need to write over ds. Because I wrote s here ds, I have to write ds on top over dt, which is the same denominator we had at the beginning. Now I'll check if I cancel ds and ds, do I get dA over dt? Yes. Now let's continue and check what we get. dA over ds, basically it's the derivative with respect to the side. So to derive, it becomes 12s. So I write 12s multiplied by ds over dt, we have it, it's equal to 2. So my final answer will be 24s. They said calculate this when s is 3 and you'll get your answer. Okay. Now, let's say we have this question. Here they're telling you estimate how much is f of 2.02 using f prime of x. So now, as long as we are talking about rate, like the previous questions, we're going to use dA over dt, dv over dt, and so on. In these questions, if we're estimating, then we need to be careful how we do it. There is a rule you should memorize, which is delta y is approximately equal to y prime multiplied by delta x. Delta y, it means a very small change in y. Y prime is the derivative, delta x is very small change in x. Now, knowing this rule, instead of y and x, you can replace whatever you want. Like if you want to call the function f, so you say delta f is approximately equal to f prime of x times delta x. If you're talking about a change in volume, you can write delta v is approximately equal to v prime, so the derivative of the volume times the volume is related to the radius, so delta r. If it's area, you can write delta A is approximately equal to A prime times delta R. Okay, so it depends on the question you have. So here we have F. Now, back to this question. I want to calculate F of 2.02. Clearly, the main X, this is not the main one. This is after the change we got X to be 2.02. The main X was only 2, and the small change we had is the 0.02. So delta x basically is the 0.02. Knowing this, I will write f of the bigger x, which is 2.02, minus f of the main x, 2, is approximately equal the derivative of the main x, which is 2, times delta x, which is 2.02 minus 2, but we already wrote it, it's 0.02. Now, do I have f of 2? Not yet, but I can find it because I have the function f. you can replace 2 there and you'll get the answer. Do I have f prime of 2? No, but I can find the derivative and replace 2 there, and 0.02 is a number. So let's check what we can do. F of 2.02 minus f of 2, when you replace 2, I'll do it here, it will be 3 times 2 squared, which is 4, minus 2 times 2. So 3 times 4 is 12, minus 4, and we get 8, so minus 8, approximately equal to. Now we find f prime of x at first, so 6x minus 2, and then we replace 2 there. It will be 6 times 2 minus 2, so 12 minus 2, it will be 10. So approximately 10 times 0.02. So the approximation of f of 2.02 is approximately equal. You can calculate this, it's 0.2. And the negative 8 goes to the other side, will be plus 8. And we get our answer to be approximately 8.2. Now, if they want the exact value of f of 2.02, you just go back to f and replace 2.02, but the question is estimate.